Hello, my name is Oren Barry, and today I'm going to be talking about how mechanical engineering has contributed to the exploration and development of the Arctic. To do this, there are a few main points that I'm going to cover to explain this topic fully. And the first is the history of exploration in the Arctic. And the second is the reason why many of these expeditions failed. And the third is how technological advances have made it possible to navigate in the Arctic and therefore further exploration and development in general. A lot of the early Arctic expeditions were directed in a focus to discover the fabled Northwest Passage. The major reason that the Americas were even discovered in the first place was in search of an easier trade route to Asia than the existing land trade route. This trade drive led to the funding of the initial exploration expeditions into the Arctic. But many, if not most, of these expeditions were abandoned as hopeless, and others actually came to tragic ends for both ship and crew. To illustrate my point of this need of engineering innovation, I want to touch on two main failed expeditions really quickly. In 1845, Sir John Franklin, a British Royal Navy officer, was commissioned to spearhead an expedition of 2 ships in search of the Northwest Passage. In the early stages of this expedition, just inside the Arctic Circle, both of these ships became lodged in heavy ice flow and were rendered completely immobile. Ultimately, both ships and their entire crews of roughly 129 men were lost. In fact, it would be another 5 years until the remnants of these ships were even discovered by rescue teams of both American and British ships. The frigid water and heavy ice buildup proved fatal to Franklin's expedition and crew. Another failed expedition of note was the RV Belgica, captained by Adrian de Gerlache. The Belgica departed late in the year of 1897 and crossed the Arctic Circle in February of 1898. It, like Franklin's expedition, became lodged in pack ice. The smaller crew of 23 men were forced to spend nearly an entire year lodged in the ice, unable to move. The crew, spurred by desperation, were able to dislodge the Belgica in February 1899, and after months of repair, were able to limp back across the unforgiving Arctic border to safety. Now, obviously both of these expeditions met similar ends because their ships weren't up to the task of navigating the harsh Arctic Sea. They were crossing ice-infested waters with ships like these, when they should have been using ships like this. Well, ships like this. This is a nuclear-powered Arctic ice-breaking barge, quite fittingly named the Arctica. The concept of icebreaker ships has actually been tossed around for centuries, some even as early as the Viking Age. But the technology simply wasn't there until the early 1900s. This class of icebreaker entered operations in 1957, and in 1975, the Arctica became the first surface ship to reach the North Pole, an impressive feat made possible only by specifically engineered design features that are seen in these ships. Firstly, they are built with fortified hulls, especially around the waterline, and backed with internal structural supports to maintain hull integrity and act as a battering ram of sorts to cut through the thick Arctic ice buildup. But with that armament and size upgrade comes the need for a propulsion system that is up to the task. Thus, the nuclear-powered propulsion was used. Size and strength alone, however, simply are not enough to conquer the frozen mass that is the Arctic. When it comes to penetrating massive ice buildup, simply pushing through it takes a lot of energy and time, subjecting the ship to massive amounts of wear and tear and metal fatigue. The Arctica, and many icebreakers like her, are specifically designed to break and channel the ice beneath or around the ship, instead of simply ramming through it. This means a specialized hull shape to promote the ice flow and channel it in the direction, as well as enhanced propulsion systems that can withstand the battering of continuous large ice flow debris, all of which are made possible through teams and teams of builders, naval architects, and engineers. In conclusion, without the advancements by naval architects, engineers, and others, none of this Arctic activity would have even been possible. Entire trade routes and research expeditions and exploration excursions would have never even been approved, or they would have died in the early stages of travel. It'll be really interesting to see what advances we made in this field of research in the future, and especially the fruits that will come from these expeditions. This has been an Oren Barry production. Thanks for watching.